Good morning, students. So today's class we are going to study about the differentiation based QRS detection techniques. So in this differentiation based method, our aim is to detect the QRS complex alone. QRS complex is a very high frequency signal. So we have to differentiate the ECG signal in such a way that we have to eliminate the low frequencies which is present in the signal like P wave and T wave should be eliminated. So we have two different methods are there in this differentiation based QRS detection technique. In the first method, is a very simple process. We can detect the presence of QRS complex and estimate the width of it. In the second method, it is an elaborate system so that we can recognize the QRS complex based on analysis of the slope, amplitude and width of its morphology. So first let us study about a simple high-speed QRS with detection technique. So in this method, first of all, the ECG signal, to the ECG signal, we have to apply the first order derivative and second derivative to obtain the signal, and we have to apply the rectification process to detect the QRS complex from the signal. Then we can able to measure the width of the pulse, so which is equivalent to the QRS duration. So the initial step is, since the ECG signal has some noises are there, so we have to remove that noise. For that we have to apply the band pass filter. So if the band pass filter is applied, we can able to remove any low frequency drift which is present. Low frequency drift means, in the ECG signal before the P wave you have the baseline. So that baseline sometimes it will tilt to some angle either in the upward direction or it will be tilted to some angle in the downward direction. So that we call it as a drifter, or we can call it as a baseline wandering effect. So that can be removed by using this band pass filter. And also if there is sometimes the P wave, the high frequency noise, it gets overlap with the P wave. And so we can detect the P wave as a QRS complex by mistake. So to overcome that, as an initial step, we have to apply band pass filter to remove any baseline wandering effect or the high frequency noise which is present in the signal. So initial step is application of band pass filter. Then the next step is we have to differentiate the ECG signal. Now, if you see the ECG signal, the signal it is given by y naught of nt equal to x of np minus x of nt minus 2t. So what is the meaning of this equation? Here this equation itself denotes nt represents the signal is already sampled. So at time period t equal to n into t, the signal is already sampled. Now in this equation, the output y naught of nt represents the output signal, which is nothing but the ECG signal. So that is equivalent to x of nt, which means the input signal, the ECG signal which is obtained at that particular instant of time, minus the signal which is obtained after a 2 seconds delay. So that is why it is represented by nt minus 2t. So the differentiated signal, it is given by the ECG signal which is attained at that particular instant of time minus the ECG signal attained after 2 seconds delay. So that difference we call it as the first order differentiated signal. So then the second derivative is, if you apply the first order to the first order derivative, if you apply the second time, if you apply the differentiation operation, we can get the second derivative of ECG waveform. So which is denoted by yn of n, y1 of nt. So this is equal to the ECG signal obtained at a particular instant of time x of nt minus twice x of nt minus 2t plus x of nt minus 4t. That means the ECG signal obtained at that particular period of time minus twice of the signal which is obtained with the 2 seconds delay plus the signal which is obtained with the 4 seconds delay. So in that we adding all these things. The next is the first order derivative equation and the second order derivative equation is added so that we can able to perform the smoothing operation. So the smoothing operation, it is given by denoted by y naught of Sm of nt equal to 1 by 4 of y naught of nt plus twice y naught of nt minus t plus y naught of nt minus 2t. So which means we are adding those two derivative signal and then perform smoothing operation. So y naught of nt represent what is the output signal obtained at that particular instant of time plus the output signal obtained after a 1 second delay plus the output signal obtained after a 2 seconds delay. So all these things are added here to obtain the smoothened signal. Next, after applying the smoothened signal for the first order derivative, next we have to apply it for the second order derivative. For the second order derivative, if you see, it is represented by y1 of Sm of nt. So, which is equivalent to 1 by 4 of y1 of nt plus 2is y1 of nt minus t plus y1 of nt minus 2t. So, then after applying the second order derivative to the smoothening process, that is smoothening process to the second order derivative, so we'll be getting this equation. So both the first order derivative output and second order derivative output are summed and it is scaled by using this equation y2 of nt equal to 1.3 y0 of sm of nt plus 1.1 y1 of sm of nt. This 1.3 and 1.1 are constants used here. So after obtaining the smoothened process, the next step is we have to apply the thresholding. So the threshold according to the that is thresholding operation. So we have y2 of it should be greater than the VTH, the threshold. So that means in the signal we will be finding out the 8 succeeding points and those points are compared with the threshold. If 6 or more points are equal or exceeds the threshold level, then we can able to segment the QRS complex. Now if you see the waveform, the first step represents that P wave, T wave and all detected and it is deleted and replaced with the baseline. So only we have the QRS complex. In the next step, the first order derivative operation, it is shown here. And in the third one, second order derivative operation is applied here. Then these two are added and smoothing operation is applied. And finally, thresholding is applied to obtain the QRS complex from the signal.